What's going on? This is SDG Physics. My name is Tosh Dalday, and I like Batman. I'm going to read you a bunch of situations. I want you to tell me which one is best, which is, if this graph is linear or non-linear. You ready? Your teacher has to grade all the quizzes in this weekend. Oh, I hate doing that. He started recording how many grades he graded every 30 minutes. Do you think the relation between the number of tests he grades and the time he spent is linear or non-linear? So, does that make sense to you? Do you understand? Do you need me to baby up the sentence for you? What I mean by baby it up is, do you need me to explain it to you a little bit clearer? Say that I'm grading a test, okay? And it takes me 30 minutes to grade 10 of them. In the next 30 minutes, how many do you think I'm going to have completed? 20 of them. It might be a linear progression, right? Because it might take the same amount of time for me to grade each test. Now,
what if one test is really shitty and the other one's really good?
Well, you can't say that word, but yeah, I see what you're saying. I would say yes, this is a linear relationship.
Okay.
However, that doesn't always mean that every point on this thing is going to be a straight, or it's going to be on this line. For example, maybe we'll call this the test, and we'll call this the time. So, you know, I'll have one test graded over here, and after 30 minutes, I'll have 10 tests graded. I was going to say grestated. And then so maybe after 60 minutes, I'll have 20. But you're absolutely right, Tejas. What happens if one test takes me a particularly long time? Well, then that's going to be, you know, I'll have 11. Say maybe this 11th one was your test. And it took me a really long time to grade because it was very bad. So maybe this one comes out over here, right?
Okay. Hi, me.
Hi, you. And then the next one would be, the next one I grade is Randy's. Randy's simple. She got all the right answers, boom, done. So she doesn't even take me 10 seconds to grade. Yours took me like, I don't know, what is that? That's like 6 minutes or something. All right? And then the rest of them kind of grade, you know, graph around here. The point that I'm trying to make is this is still a linear function, even if there's what we call outliers, I suppose that's the best word for them, is I would still graph that as a line. Even though I've got like, people are going to ask me, what is that? And I'm going to be like, have you met Tejas? All right, anyway.
Thanks, Mr. Donald.
Yeah. You know I love you. All right. I suppose that somebody could make the argument that this is not a linear function because maybe they wouldn't want to get super technical about it and say, well, sure, he'll take 5 minutes to grade each test or whatever, boom, 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 which is not at that rate. But anyway, say that I take 5 minutes to grade each test or whatever. Sure, he'll do that, but maybe he gets tired. And as the night goes on, because you know, I mean, I grade my test. Actually, I don't drink wine or beer, but I mean, I grade my test late at night. I get tired and take a long time.
You do that crazy aerobic thingy that you do.
Oh yeah.
Have you ever seen he like takes off his glasses and then like goes really fast?
What do I got quarks that you're picking up on now? All right. Anyway, you go to a luau. You go to a luau, and the buffet is all you can eat. You're there for 3 hours the entire time. Do you think the amount of food you eat is linear? Explain.
What? No way. Are you kidding?
Why?
It's gonna change as you.
Why?
Because you get full.
Yeah. So your graph is probably gonna look like this. I mean, you're not gonna be like I'm gonna eat, and I'm just gonna eat more and more and more and more and more, and constantly for 3 hours straight.
I would do that, but
like I've actually been watching a lot of Man vs. Food, right? And here's how he eats like 60 hot dogs or something like that. He's like, I'm gonna eat the what did he eat the other day? A 9-pound plate of steak. 9 pounds.
How would you do that?
That is like almost I want to say almost a baby, but that's way heavier than a baby.
That's how heavy
Like
I
a
was
newborn. That's
almost.
like almost like 2 premature babies. That is ridiculous. That's like reverse giving birth
Ow.
through the mouth. Anyway, here's how it looks mainly for him: is he'll polish off the first like 5 pounds of food in like, because he has like an hour to do it, right? Or maybe let's say pretend it's 3 hours. 3 hours to do 9 pounds. All right, fine. That's even reasonable. It's not even reasonable. That's disgusting. Anyway, he'll polish off the first half of the meal like this. Boom! He eats it, and then the rest of the show is pretty much him doing. And then he's sweating, he's crying and everything, so he's barely finishing out, so he's kind of going like that, and he kind of tapers off. That is not a linear function, right? He's not eating the same amount of food for every minute that goes by. Do you understand how this linear input-output kind of thing works? All right, let's do this one. You're running on a treadmill, and don't change the speed the entire time you're running. What do you think the relationship between the distance that you've run and the amount of time that you spent running is linear? Well, first of all, if you want to get super technical, you didn't run any distance because you haven't moved anywhere. But let's pretend that, like you're looking at that little like speed or that little dial that says you've run this many miles. Is that linear?
Well, how many miles are we going? And how
Does
fast are you going?
Does it matter?
Doesn't it?
You're running on a treadmill. You don't change the speed. You don't turn up the dial. You don't turn down the dial.
Oh, well then you're going straight.
Yeah.
Well, of course you're going straight. You're not going anywhere. I don't understand how you're going straight. But what are you talking about straight? Come on, I need answers from this side. I keep teasing this guy that this guy's not smart and he's giving all the answers. What does that say?
Staying at the same speed.
You're staying at the same speed. Is it linear?
Yeah.
What?
Yes.
Yes, yeah,
I couldn't
exactly.
hear on this end.
The amount of time that you spend, the more time you spend, the further you'll go. Does that make sense? And that graph, unless you're speeding up or slowing down, you'll be going kind of your distance that you change is going to be constant as your time increases, as your time changes. That goes along with the definition of linear. All right, here we go. You're running on the treadmill, but this time you start off at a slow speed and steadily increase to a speed to get a better workout. Do you think the relationship between the distance that you have fun and the time
Wait, what?
you're running is linear? That's what it says. That the distance. Do you think the relationship between the distance that you have fun and the time running is linear? A, that question doesn't make any sense at all. It should be dragged outside and shot with a shotgun. B, what do you think the answer is?
I'm just gonna go with linear.
We had fun.
No. I'm not talking about fun. I'm talking about the distance you traveled and the time you spent on the treadmill. Is that linear?
Yeah.
All right, no. Here, I'll explain the situation to you. I'm running, and Tejas doesn't like me because I keep teasing him. So he comes up to the dial. He slowly starts turning up the dial. Look at that.
You would do that.
I would do that.
And then, like after
Really
3
do
hours,
that.
I'm like this. Is that
You would do that.
the distance that I traveled? Is that constant? What I mean by constant, I don't know if the constant is the best word. Is the amount of distance that I've traveled changing by a constant number?
No, because I turn up the dial. So
So-
You turn
from
it
the
way
time that
more.
you're running normal to the time I plot my revenge.
So here, I got a challenge for you. In fact, why don't you come up and sit to the board? It's not linear, so it's not going to be a line. What is the graph going to look like if this is time and this is d, as in distance? What do you think it's going to look like? I'm just curious. Go.
Like, the
So
stairs kind
you're
of
going
thing.
at like a constant rate at first, but you are increasing your distance.
See, he needs to learn how to write it on a chalkboard because he's actually doing this really. No one can see what I'm
I'm
talking
sorry.
about. It's actually looks kind of shady what I'm doing.
then you go up like that.
All right. What do you guys think?
Yeah.
I can dig it. Shoots, bro. Up out.